Binomial model. Consider a two-period binomial model of a stock whose current price S0 is equals to 100. Suppose that over each of the next two periods, the stock price can either move up by 10% or move down by 10%. Continuously compounded risk-free rate is R is equals to 8% per period. Show that there is no arbitrage in the market and calculate the price of 1 year European call option with strike price K equals to 100. So we need to calculate the binomial tree. So this is question 1. Part 1 is binomial tree to us. Now first part is show that there is no arbitrage in the market. So in order to avoid arbitrage, we must have D less than e to the power R less than U. Okay, this is the case here since D is equal to 0.9, U is equal to 1.1, R is equal to 0.08. So e to the power R is equals to 1.0833. Okay, it lies between this second part. First we have to calculate the Q. So e to the power backslash delta t minus d divided by u minus d. Okay, so e to the power 0.08 into, since you have to calculate one period, so 0.08 into 1 minus 0.9 divided by 1.1 minus 0.9. This is equal to 0.9164. And once you have this, you can calculate a binomial tree. So I'll make a short table over here, since you have to make two-step binomial tree. So you need 3 columns and almost around 6 rows, because we'll start writing from in between. So let's say 7 rows I am taking. I am starting writing from in between. So 100, which is the value of V. Then we have our up probability. This goes to 110. Well, I'll just write 100 into U. If you want to write this, you can write. If you don't want to write this, you can skip. Okay, 110, and this comes to 100 into D, which is equals to 90. Okay, and the next here it is again 110 into U, which is equals to 121, and here it is equal to, so this is going up here, going down half. So 100 so this is 90 into D, which is equals to 81, and for in between we have our values from 100 and 90. So this is basically 100 into D plus 110 into D plus 90 into U, so which is equals to 99. Okay, so this is how you do this 110 into D, or you can do 90 into U. Okay, anything of this works here. And now since this is there, time, just do not forget to give time. So this is time 0, time 0.5, half yearly payments, and this is time 1. Okay, once you have got this, therefore now our payoff, you can payoffs are, for the first case it is 121. So I'll just write this here only. In fact, 21 here, there is this is 0 since this is less, and here also it is 0 since this is less than the value. So there's these just calculate V then. So V is equals to e to the power minus 2r expectation of this actuariality C given F naught. Okay, so e to the power minus 2r into 21q square plus 0 into 2q into 1, 2q into 1 minus q plus 0 into 1 minus q square and bracket close. So this is equals to e to the power minus 0.16 into 17.6369, which is equals to 15.029. Okay, so this is how you calculate binomial tree in Excel. Doing one more sum. Assume a 2-period binomial tree. Okay, two non-period binomial tree, non-dividend paying stock whose current price is S not equal to 100. Assume that over 6-month period the stock price can be either move up by factor U equals to 1.2 or down by factor 0.8. Continuously risk-free market R is equal to 5% per 6 months. Prove that there is no arbitrage in the market. Construct the binomial tree. So again, it's almost the same thing, actually not almost, exactly the same thing with different values. So part 1A, to avoid arbitrage in the market, D must be less than e to the power r must be less than u. Here u is equals to 1.2, d is equals to 0.8, r is equals to 5%. So e to the power r is equals to e to the power 0.05, which is equals to 1.0513. Okay, so the inequality holds. Now next part, again consider the construction of binomial tree. So you just need to insert your values, finding so insert table, okay, some sort of taking value in between. The value starts from 100, goes up 1 year, so 100 into u is equals to 120, and coming down 100 into d is equals to 80. Okay, and going up again 1 year, it is 120 into u, which is equals to 144. This is 120 into d or 80 into u, anything you calculate. This is 96, and here it is equals to 80 into d again, which is equals to 64. So this is my binomial tree. Time, again time, please do not 0, 0.5 and 1. And next part is, okay, this was B. Now next is part 2. Part 2 says calculate the price of a standard European call option with written on the stock is its strike price K equals to 100, maturity 1 year. So obviously now the payoff set is 144 minus 100, 0, 0 as all are less. So only 44, 0. So this is equals to only 44, 0, 0. This is my payoff set. Now it equals to q is equals to again e to the power r minus d divided by u minus d. So this is equals to e to the power 0.05 minus 0.8 divided by 1.2 minus 0.8 is equal to 0.628178. Therefore v underscore naught is equals to e to the power minus 0.1 into 44q square plus 0 plus 0. So this is equal to 15.71. Okay. Next, consider a special type of call option with strike price, key constant, maturity 1 year. The underlying asset for the special option is the average price of the stock over 1 year. Calculate it as the average of prices at times of 0, 0.5 and 1 measured in years. Calculate the initial price of the call option. Assume it can be exercised only at time 1. Okay. So as the option depends on the average past share price, which depends on the part, we need to use a non-recombining tree, and the tree below shows the average stock price inside boxes in the final payoff. So let's make this binomial tree again. So part 3 going up, I'll copy this table. Okay. Copying this table from 0 to from 100 to this u. Now we do not have to use u, we'll have to make a average of prices. So obviously 100 and plus 120 divided by 2, so this becomes 0.5 into 100 plus 120, so equals to 110, and down it will become so give some space. Okay, after 100 I'm say writing here 100, just coming down. Since this is a non-recombining tree, so say 100 is going here. I am inserting one row in between here. Let's say this is there. And this is there. I'm writing this to be here so that I have one space, and this is again 0.5 into 100 plus 80 is equals to 90. Then you have this going up. So going up, this is equals to 1 by 3 into 100 plus 120 plus 96, which is equals to 121.33. Next it was, when I come down, this was equal for this step, this was equal to 1 by 3 into 100 plus 110 plus 120 plus down value was equal to, we had this recombining tree, what was the down value equal to? 96. Okay, then coming here also, this one, this is going up again 1 by 3 into 100 plus 900 plus 80 plus 96, and this is also, when I come down, 1 by 3 into 100 plus 80 plus, what was it, down 64, which is equals to 81.33. Here it is equal to 92. Here it is equal to 5 105.33. So this is how this non-recombining binomial tree is there. Payoff is the cells 121.33 minus 100 105.33 minus 100 comma 0 comma 0. So this is equals to 21.33 comma 5.33 comma 0 comma 0. Okay, and then E naught is equals to e to the power minus 0.01 in brackets 21.33 q square plus 5.33 into q into 1 minus q. Non-recombining tree, so this will not be into 2, and then this is equals to 8.74. Okay, so this is how you calculate binomial trees.